On Physics with Clyde.
Circular motion, it is everywhere, but what is it exactly?
That's a great question. Let I, the spirit of physics, answer it. Here is an object in uniform circular motion. Objects in uniform circular motion have a constant speed. However, their velocity is not constant as the motion's direction is always changing. This velocity is also called inertia, as is where the object in motion wants to go, and it's always tangent to the circle it moves in. So, there must be an acceleration that changes the velocity. We get this acceleration when we take the velocity at two different points. We can see that the change in velocity, which is the acceleration, always points to the center. This is the centripetal force, and it's what drives the circular motion.
Now you guys understand the basic concept of circular motion. Let's find some real life example. Nice to meet you. So you know how the swing works?
Oh yeah, I know how a swing works.
Let's analyze the forces acting on the swing. To start, we have the gravitational force, which is pulling the whole system, including the swing and Ethan, down. Next, we have the tension force in the rope, which has to keep the swing up against gravity. Something that might be mistaken as a force but isn't is the inertia of the swing. Once the force being applied to the swing is given, the swing moves with its inertia, and circular motion keeps the swing moving. Here, while the swing is in motion, the tension in the rope of the swing has to both fight against gravity and provide the centripetal acceleration to keep the swing moving and stop it from flying away. On a different swing, we see the cable starts to have slack near the top. As the swing gets higher, there's less tension in the rope, as it stops working against gravitational force, but instead with it to provide the centripetal acceleration.
When's the last time you watched a video? Let's get back to the interview. I found a wild cowboy outside of school. Let's ask his name. Hi sir, what's your name?
Hi, my name is Julius Chad, but around here, they call me Cowboy Chad.
Do you know anything about circular motion?
No, what is that?
It's just something moving in the circle.
Oh, like my lasso over here?
Wow, that's impressive. When's the last time you used it?
I got you now!
As the rope is being swung by Cowboy Chad, he applies a tension force in the rope to keep it swinging and to maintain a circular motion. As he swings faster and faster, the inertia in the rope is built up and also becomes greater. When he releases the rope, the tension will no longer exist and the inertia of the rope will keep it moving, sending it to capture the other cowboy.
Hi everyone, here we find a new person to interview. Hi sir, what's your name?
I'm Rila.
And what are you doing?
I'm doing my physics project.
What is it about?
It's about like circular motion. You see,
Perfect.
there's some water here. And if I spin, it won't drop.
Well, can I demonstrate?
Sure.
In Raymond's physics experiment, the water doesn't fall out of the spinning cup. From Newton's second law, we know the net force gives the acceleration to the system. It is the same for centripetal acceleration. Here, the gravity applies the centripetal acceleration at the top. So if the cup is being spun fast enough, the water's centripetal acceleration will be equal to gravity, and thus it will not fall out of the cup.
Wow. Looks like you control it completely.
Yeah.
Oh!
You know you'll have to pay my clothes.